This is Joel, and today I'm back with another video on VPNs. We'll be looking at using the CA servers for authentication purposes while configuring VPNs, right? So this is basically the entire discussion is concentrated or focused mainly on the phase one of a IPSec VPN configuration, right? So if you remember, during the phase one, we normally used to use something called as a pre-shared key, right? PSK, and this pre-shared key was always configured or statically configured between configured at both the sides, both the ends, right? And if you use the same key over time, there is always a chance of brute force dictionary attack. So we are going to move towards something called as a PKI infrastructure, right? Public key infrastructure, and this public key infrastructure basically uses the public keys and the private keys of the devices, right? For more information, you can go detail and look at the Cisco documentation. Let me quickly give a brief on how we are going to do this. So in the network, we are basically going to create one particular device as my CA server. In this case, R2 will act as a CA server. So CA server is basically certificate. CA stands for certificate authority, and CA server is an entity uh, which basically authenticates, verifies, right, the devices and issues certain you can call them as passports, right? Just like a country issues passports for its citizens, you can assume CA authority to be CA server basically is one such entity which offers or which provides the IDs, right, certificates for my devices. So how this works is R1 and R3 are going to generate public key, private key on their own devices, and then they are going to send their public key towards R2, right? And R2 now will verify, and it will send back a certificate, right? We call this as a ID certificate. So R2, which is the CA server, will send the ID certificate back in this direction towards R1 and R3, right? Now, when the authentication has to happen between an R1 and R3, how this works is R1 will request R3 for its public key, right? And when R3 responds with the so R3 has received the message from R1 asking for its public key. So R3 will return or reply back with its certificate which it has received from my R2. R1 looks at the certificates and sees that this particular certificate has been signed by CS server, which is R2, and because CS server is something you can trust, so R1 will trust and will assume that yes, the certificate which I received just now is actually of R3. So that is where the validation happens. Now once it has received the certificate, it now knows the public key of my R3, right, because the certificate basically has that information. So once it receives the public key of R3, it will encrypt all the data which it has to send towards R3 using this public key. R3 will now receive the information, encrypted information, but it will use its private key to decrypt the information, right? So we were able to achieve everything. We were able to validate, we were also able to encrypt and hash the information going in between the sites. So that's what we are going to do today. Let's start with configuring my R2, which is my CS server, right? Let me clear the screen a bit. Great. So what do we do on R2, right? Pretty simple. Let's do some IP configuration to begin with, right? Let's do that, right? So let's do the IP configuration, and then let's also put a routing protocol because we would need that, right? So on my Ethernet, I'm talking about R2, so I have two interfaces, 0/0 and 0/1. So on my 0/0, I'm going to put 192.168.12.2. This is going to be 12.2, and this will be 192.168.23.2, right? So we have these two networks. I mean, I have put the networks over here for better readability, right? So I'm going to use 12.2 over here and 23.2 over here, and the loopback interface is going to be 10.2.2.2. We have a loopback interface on the CS server, and I also put a very basic routing called as the basic EHRP, right? I put a no auto summary, and I also did put my network 192.168.12.0, 23.0 and 10.0, which is all three networks which I have on this router, right? So that's basically my routing part, which looks good. Now some of the prerequisites which are very much necessary while configuring a CS server is that whole of the network should have the same time and the same there should be a sync, right? Because if there is no sync, then what happens is if the certificates which are issued, they basically have a lifetime. So if this router is in probably having a time which is saying 2018, and if these routers have been configured to 2015, what happens is probably the certificates which are issued by this router might not be valid on them, right? So there should be like a time synchronization happening. You can use NTP and so on, but I'm going to use something very simple over here. I'm going to hard code, and I'm going to tell, hey, this time zone is GST +4 and my time is like 5:18 and the day is like 27th August 2017, right? I'm going to put that. It could be anything for now. I'm just using the same value on all my three routers. Let me also go ahead and do the next thing. Basically is I'll have to generate my public key and private key on this CS server, right? So let's do that. For that, what we have to do is we need to just use this crypto command, and you will be done with that, right? So this is going to be my crypto command. Crypto key generate RSA modulus 1024 label. Just use a label which we'll again use later as well. So I'm going to use iOS CA as my label, right? There you go. So I have created my private key, public key. The key pair has been created. Now the next is all the communication which happens between my devices and the CS server happens using HTTP. So I need to have a HTTP server on my CS. I need to have a HTTP web server set up on the CA, right? So let's do that. There you go. I did that. Now the last part of the configuration is where I do the configuration for my CA parameters, right? So this is how we do. So configure CA server parameters. What we do is we start with the crypto PKI server, right? We need to use the same name which we used earlier while creating the keys. Now that's how it identifies which keys to use. So iOS, we're going to use iOS CA over here, right? The next is database. So this is a device this is a server, so it will be issuing a lot of certificates, so it should have a location for storing them, right? So this will be the place where, I'm going to use the NVRAM for now. You can use flash and so on. The next is, these are a couple of information we need to mention for the certificate, right? So I'm going to issue a name, right? And then I am going to issue a name. The certificate name basically would be ABC, the server, right? The CS server, right? The name of the CS server which is issuing, I'm gonna name it for now as ABC CS server. The organization is ABC. Organization unit is, I'm gonna call it as training. Location is Dubai. Country is India, and so on, right? So you can use that. Grant auto is a command which basically tells the CS server to automatically grant certificates, right? Credit whenever you get a request. You can put in a lot of other kind of checks, like you can do a CRL, and you can check the revocation list and so on. But for now, to keep it simple, I'm going to use grant auto, right? So let's do that. We've done that, and now let's do a no shut. There you go. So when I did a no shut, it's asking me for a password. So let's put in the password. I'm going to tell you why I'm going to use this password later. Yeah, so I use the password, and you can see status message which says certificate server enabled. Now why did I use a password? Because let's say you want to someday remove this particular certificate. You no longer want to use it. So during that time, that it will again ask you for the password, right? It will ask you if you really want to delete this certificate. I mean, in that case, you will have to retype the password. So that's the reason why we use the password. So that was all the configuration which happens on the CS server, right? Now let's go down to my R1 and R3, right? So let's do the same task wherein we start with doing the IP configuration or the routing part, right? So let's do that. So let's go to my terminal. There you go. So I'm gonna put some IP address on my Ethernet interface, right? And which is Ethernet 0/0, right? This is the interface. I'm gonna put 192.168 and sorry, this interface I'm gonna use 12.1, and for this interface I'm gonna use 13.1, right? And the loopback interface is 10.1.1.1, right? I'm gonna use that, and I'm gonna put a EIGRP protocol as well, like earlier, right? So that is done, right? How about I also do a couple of other things, right? Or this is pretty simple. Let me go and do the routing on R3 as well, right? So that we can do everything together. That'll be easy, right? So R3 is my other site, right? So let's do the IP address configuration over here. So we have 0/1, 0/2, right? 0/1, 0/2, loopback interface 10.3.3.3, and the routing. Sweet. That's good. Now what do we do next? So we are on the client side, right? Just like what we did on the CS server, we need to have a uniform time being used everywhere. So I'm going to use or I'm going to configure the time now, right? So I'm going to configure it to be the same time as earlier, right? So there you go. That is done. Let me do that on R3 as well. The configurations becomes very easy when you do it step by step, right? So that's why I'm going to do it simultaneously on both the routers. So we have done the time configuration. The next is what we did earlier was we generated the keys, right? We generated the RSA keys, because public key and private key is very much needed for this entire communication to work. So I'm going to do that again. I'm going to do that on both of them, right? So this is the command, crypto key generate. This is basically the size of the bits, RSA modules, and that's basically going to do my generation of the keys, right? That's good. Let me do that on R3 as well. There you go. That's done. Next, what do we do next? The next is we need to create a trust point, right? So what's a trust point here? We need to tell my router R1, right? We have to create a pointer towards my CS server, right? Otherwise, how will it know which is my CS server in the entire network? So on both my R1 and R3, I'm going to create something called as a trust point, which will in turn identify R2, as my CS server, right? So to do that, you need to just put in like 3 commands. Let's show that. There you go. So I'm going to define a trust point, say III, and enrollment URL is basically the HTTP 10.2.2.2, which is the loopback address here, and I'm going to use port 80 because that is nothing but the HTTP port, and we have enabled HTTP on my R2. And revocation check, I'm going to put it as none, because revocation basically is used when you want to thoroughly check if that certificate is currently valid or not. There might be chances where the company probably, or this router or this device, changed its certificate, or basically there could be a situation where it was modified, it was deleted, and you want to 100%, you want to be 100% that the certificate which you're using is valid, right? So whenever a particular certificate becomes invalid, it is put into something called as a revocation list, right? And using this command, we can actually check if that certificate is on the revocation list, or is it valid right now. So but I'm not going to do that check now, because I know that it's a very simple demo, so I'm not going to do the revocation check. I'm going to put it as none for now, right? So that should be good, right? So we did the trust point. So once you did the trust point, next what you have to do is you need to download the root certificate of the CS server, right? And for that we need to use this one. So I'm going to do that, crypto CA authenticate, right? I'm going to identify the trust point earlier. So there you go. There was an error. Sometimes it happens. You have to run it again. Okay. Let me do that again. Did I make a mistake? It is CA crypto CA authenticate, and yeah, now I got it, right? Maybe it took a couple of seconds for that. So it is asking me, do you accept this certificate? I'm going to do an yes. Yeah. So be careful whenever you do this configuration. It might take a couple of seconds, so it might fail a couple of times, but then when it works you get something like this: trust point CA certificate accepted, right? Wonderful. So we have done that. The next part what you have to do is we have to enroll the public key with the CA server and get the certificate issued. So what we have done till now is that we have pointed this router towards this, telling that R2 is my CA server, and we have also downloaded my root certificate from CA server onto my R1. Now the next thing is I need to send the public key from here, my R1's public key, towards my CA server and get the ID certificate issued, right? Because that will be in turn used later during my encryption process. So I need to do that. I need to get the ID certificate, right? So we have to enroll. So for enrolling we need to do this. So it will ask you a couple of things. It will ask you for the password again, right? So you can use a password here. I use the same one everywhere. Include the router serial number in the subject name. Okay, let's put a yes. Include IP address, maybe not. Request certificate from CA. Yes, please send me the certificate. There you go. The certificate was issued, right? So that is done. So those were the 3 steps, right? The configuring of trust point, then downloading of the root certificate, and then also sending my public key and downloading my getting back my ID certificate. Let's do these 3 steps on my R3 as well, right? So let's do the trust point first. There you go. The trust point is done. Same configuration like what we did last time. This is little tricky. Let's be careful here. It might, okay, it issued right away. So let's put in, do you accept this certificate? Yes, I do. That's good. Now let's enroll. Right? While enrolling, what happens is we are basically sending the public key and telling CA to issue a ID certificate for me. So I did that. It is asking for password. Let's go 1 2 3. Include the router serial name. Yeah, let's put that. Include IP address, probably no. Request certificate from CA. Yes, please. There you go. The certificate was issued. That's pretty much the 3 steps we needed for the certificate. Now what is left? What do we want? What is our final goal? We need to have a VPN between these two, right? And we have done the VPN configuration a number of times. We do the phase 1, phase 2, and then we apply that crypto map on the interface. That is only what we used to do. So we're going to do the same thing with a small change, right? In phase 1 we are no longer going to use pre-shared keys. Instead we are going to use the PKI infrastructure, right? So this is how the crypto or the VPN IPSec configuration looks. So let me pull that up here. So I'm going to do that on R1. So on R1 you can see phase 1 we are going to put a ISACM policy. This is the only change. We tell that authentication basically has to be RSA signature, right? That is the change, because earlier it was pre-share over here, now it is RSA signature. Encryption hash group you define, right? Very much required for any IPsec tunnel we have done till now. Phase 2 again pretty much the same. I'm going to use triple des and I'm going to use SHA over here. Then I'm going to define my interesting traffic using access list. I'm going to tell any traffic which goes from 10.1 towards 10.3.3, please encrypt it, right, on this particular session, right? So we are going to do that, and then we define a crypto map and match the address, this one, set the peer which is 192.168.13.3, set the transform set, interface ethernet 0/2, and crypto map cmap, right? That's because we are applying the crypto map on the interface. I think that should be good. Let's apply this, right? So we have done that. Now the last part remaining is we have to do the same configuration on my other side, right, which is R3. So the only change would be the phase 1 is going to remain same, phase 2 also will remain same, only the access list addresses are changed here. It is 10.3 going towards 10.1, because we earlier talked about encrypting the data from going from R1 to R3. Now we need to have another direction which is from R3 to R1, so that's why we do this. We also define a crypto map right, which is matching the access list, setting the peer and transform set, right, and Ethernet. I also have an interface 0/2 on this one, on which I'm going to apply my crypto map. Looks good. Yes, so there you go. You can see my IPSec imp is on now, right? Now let's see if it works. What we do, we need to ping, right, because otherwise we would not be able to see. So let's do this. Let's clear the screen, right? Let's see if my show certificates, right? Let's see if that works, or probably it is show crypto certificates probably. Okay, let me see what's the actual command. It is show crypto PKI, my bad. There you go. So this is how you check your certificate. So this is my certificate on R1. You can see here the issuer is there, which we had already put in, right? The subject, serial number is also there, right? Then what do we have here? So this is the certificate. We have validity, so this certificate goes till 2020, right? The default time we haven't changed, so it goes till 2020. And issuer and all of this information, yeah, that's good. So we have the certificates now. Now what do? We need to, let's also check my tunnels or phase 1. What has happened? Show crypto IPSec camp. Yes, here. Okay, there's nothing phase 1, right? Let's also see my phase 2. Yeah, there's nothing, everything is 0, right? So now what we do is we have to ping now. Let's ping my R3, which is 10.3.3.3. let's source it from 10.1.1.1, right? There you go, that works, right? Let's see my IPSec phase 1 and phase 2 how it looks. Show crypto IPSec imp. Say, there you go, we have the tunnel created. Let's also see my phase 2, and you can see the packets going from R1 to R3, right? So that was basically what I wanted to show you guys. What we did was we used certificate authority, or we used the digital certificates basically for authenticating in my phase 1 stage of my IPSec VPNs, and the rest everything is basically the same, right? So I would say this is more secure and a better approach, or a best practice, instead of using the pre-shared keys, which were basically like static keys on both the routers, right? So this is more secure than that, right? So yeah, thank you.